Hello everyone and welcome to the 2 p.m. session of the 2015 Open Simulator Community Conference. As a reminder to our in-world and web audience, you can view the full conference schedule at conference.opensimulator.org and tweet your questions or comments to @OpenSimCC with the hashtag OSCC15. This hour we're happy to introduce the terrific session called RezMela, adding real-world spatial context to virtual training exercises to improve their effectiveness. Our speaker today is Ramesh Ramalal. Ramesh Ramalal is a PhD in Computer Science, Lancaster University, UK, BTech Computer Science and Engineering, ITT, Kanpur, India, and has been developing immersive virtual learning environments for diverse user groups during the past 7 years on platforms that include Second Life and OpenSim. He is currently the CEO, CTO of DeepSemaphore LLC and e-learning and simulation solutions company. Welcome all, and let's begin the session.
Hello everyone. I'm very happy to be here. Thanks for the opportunity. Special thanks to the people organizing this conference. And so today I'm going to speak about our latest improvements to the RezMela system. So the topic of my talk today is how we are adding real-world spatial context to our training exercises in virtual worlds, why we are doing it, and what the advantages we see when we introduce this functionality. Okay. Before proceeding, I would like to thank my really fantastic team that includes Jayashree Bidese, John Hopkin, Dave Hanneman, and we actually divide the team into two groups: those that do technology development and those that focus on evaluation of the system. And it's like a bird, and you need really those two wings to fly. I really appreciate the help that these folks have given me so far. They're really star team members, I should say. Okay. All right, so our original goal, just so that I don't just start abruptly about the advanced functionalities of RezMela, I'm going to give you a brief overview of what it is, and then we'll go into how we are adding spatial context using this application. Okay, so when we designed RezMela, those were our core design goals. We wanted to make it easy for subject matter experts, emergency preparedness experts, for example, or teachers in various domains who may not have the 3D design skills or programming skills. We wanted to make it easy for them to create their virtual environment and potentially in real time. That is during the duration of a class situation. Okay, so we wanted the environment to involve zero programming or scripting, minimal configuration, and we wanted it to be a real-time solution in the sense that when you're thinking of an environment that you want, you have an interface that allows you to do it. So we want to shorten the path between thought and virtual environment generation. Okay, and the other thing also is that we wanted this process to be scalable. Okay, we didn't want it to be limited by the area over which the virtual environment is deployed. Okay, and in the following examples, I will illustrate how we are doing it for. In our case, we are using an environment which is like a 512 by 512 meters, and the whole system is hosted on Kitely at this time. I have to thank the Kitely people as well, and they are really, very useful. They have been really useful to and helpful to our effort. So, just a few points about the current. We wanted our platform to support diverse learning styles and contexts. Okay, we wanted really to create a unified virtual learning platform. Typically, when we talk about online learning, we talk in terms of dyads. Whether it's self-paced as opposed to instructor-led, single user as opposed to team or collaborative environment, synchronous, asynchronous, problem-based learning versus show and tell, classroom-oriented versus field-oriented, and even at the evaluation competency of the evaluation of students, we tend to group the various approaches into two groups, whether they are quantitative or qualitative. Okay, and when we were designing RezMela, we wanted to make sure that we try to provide opportunities for all these mechanisms to take place, because learning has to take. We wanted to provide a tool that allows the instructor to weave through, to create a learning experience that actually weaves through all these various mechanisms. Okay, we wanted to provide the opportunity for teachers and students to switch from one style to the next seamlessly, and of course we want to do this elegantly. Okay, so that it's fairly straightforward to make it happen. Okay, RezMela, just some information about the name. It's just a portmanteau of two things, of Rez and Mela. Rez is to generate, create. Mela is a Hindi word for festival. So it's like a creation festival. So the core design elements of RezMela is, one is that it is an in-world collaborative scene building application. And the whole interface is within the environment, so that even if the environment is totally immersive, whether you're accessing through a 3D head-mounted display device, it would work. And it has another main component, which is the visual database, which is like an inventory of objects that populate the library, and these objects so far are actually in very different categories. You've got people, vehicles, and objects which are really quite advanced. You can have road networks with population, with people that are allowed to follow tracks on the various road networks. We make extensive use of non-player characters, and you can have library objects that include buildings with non-player characters in them. And we have other classes of objects that are servers that you need. For example, we have scoring servers that you need for advanced applications, such as a car racing game. You would actually don't need to create anything from scratch. You just drop in your score server, drop in your road network, and then drop in the cars, and you can set up your environment for the game. And right now the environment is running on a 512 by 512 region. Okay. Okay, now we come to the meat of this talk, which is you know, how we are why we are adding spatial context and how we are doing it. All right. The motivation is that training exercises embedded in real-world spatial contexts often feel more relevant both to trainers and trainees. There are many reasons for that. One is that you don't have to construct, you know, hypothetical scenarios such as if you can learn something in the virtual, then you will be able to save money, and instead of having, you know, real world exercises, etc. And then, you know, you hope that you can transfer things that you learn from the virtual into the real. Okay, so traditionally, exercises have been designed for generic, hypothetical, or imaginary places, mainly because it's a cost issue. Training competencies are expected to be place agnostic. That's another argument that we make as designers to push generic, hypothetical, imaginary places. So we say that, you know, you want to learn things, and they need the competencies that you will acquire have to be place agnostic anyway. They have to be universal. So whatever you learn in the virtual should be transferable in the real. But that doesn't always work, you know, in a straightforward manner like that. There are many more complex issues that arise. And in our experience, the cost of creating virtual training scenarios involving real world places is typically high, especially if you want to have a high fidelity of content. So our approach is kind of like, even though we can't like create like a fully high fidelity rendering of a real world environment, you know, very quickly, we're trying to reach there. And I'll explain, you know, what are the challenges we are facing and how we hope to address them. Okay, and one advantage that we think this approach will bring when we add spatial real world spatial context in our case is that it actually moves the application from the training space into a response planning application, so that when an event is unfolding in the real world, you want to provide an opportunity for people responding to that event to actually log in at the same time and sketch an approximate environment that depicts the ongoing situation, and let people try to plan a response. Okay, so we move from training from a training application to a response planning application. All right, let me see. Next slide. So this is a quick overview of the RezMela user interface. That's the latest embodiment of it. So you have, it's basically a big board, and you pick objects from the visual database and you place it on the big board, which is like a map of the whole region, and the objects will emerge at the corresponding locations in the larger virtual world, which is the immersive environment. The board actually is in a classroom situation. Okay, so you can have students in a classroom situation discussing about an event, and the teacher discussing about the scenario and creating the environment while speaking about it. Okay, we have the library objects are organized in various object categories. You can create scenes and save them and load them, etc. So if you want, you could actually prepare your scenarios ahead of time and load them very quickly too. So this is just an example of a generic virtual training space that does not have a real-world counterpart. You know, it's just an exercise involving a container truck accident, and there's a gas leak. I just wanted to illustrate that on the big board, it's all these objects have just been placed there, just based on the imagination of the teacher. Okay, it's not directly really relevant to a real world situation, but we hope that by immersing students in this environment, they can actually practice, their emergency preparedness skills. I'm not going to go into the details of the content of the library. There's just no time today. So that's like a view that gives you a more complete presentation of the current environment. So you have the visual database on the right, the big board at the center, and on the left we have a teleport station. Currently, you click on this little map on the left to emerge at the corresponding location in the 3D world. There are various. We spent a lot of time finding out what is the best way for people to emerge into the virtual environment, and once they emerge there at a specific location in the immersive environment, how they get to come back very quickly into the classroom situation. So there's a lot of design issues that comes into play, and one of the examples I can that inspired us maybe is I don't know if you remember the movie Stargate. It's like when you go to somewhere else, you have that gate that is open in the new location, and you have to go back through the gate so that you get to your original location. So we have kind of a similar thing happening here. When you click on the teleport map, you emerge into the 3D environment, and then there's a little gate behind the avatar. And after they do their thing in the immersive 3D environment, they can jump into that portal and pop up here again. Anyway, that's a detail. There are many such details, and I don't want to distract from the main aspect of this, from the main point of this talk. And one of the library of objects that RezMela provides is called the Google Map object. What it is basically, it's just a frame that you can place on the board that takes up the whole space of the board, and you can enter any location in a dialog box, or you can type in the coordinates that you're interested in, and you get a view. A Google map displayed on the board. And you can zoom in, you can zoom out. Of course, the constraints are, the resolution of the textures that the Google Map API provides. All right. So there are constraints on two sides. One is on the Google Map side, where the resolution of the images themselves is an issue. And then, of course, there's the resolution of constraints imposed by the platform, the OpenSim platform. Okay. All right. So now we have an easy way for us to place a map on the board, and the same map is going to appear. I'm clicking on the next slide here. On a larger in the immersive terrain. So what I'll do next is load a few slides that describes a few exercises that we did that involves real world settings. Okay, so if you look at the list of things in this dialog box, you have the 2015 Philadelphia train derailment. Then there is another one, the Al-Zatari Camp, Jordan, etc. Those are scenes that has been saved previously that you can bring up at a click. So I'm going to go through this list of historical studies. The first one is the Philadelphia train derailment example, and then I'll show the 3 Mile Island nuclear plant accident. and the Elk River chemical leak. I'll show you the Al-Zatari camp in Jordan. That's where most of the refugees have been flocking to. And then an example on data visualization, because we found that the same approach can be used for spatial data visualization. All right, so this is showing the 2015 Philadelphia train derailment. I'm sorry about the labels because I actually thought I would finish the slides and I forgot to actually position the arrows appropriately. But you can see in the left slide we have students flying over a train that actually got derailed, and that's at the base you have the map of the actual place where the incident happened. And of course, we have on the next slide the immersive view. This is the 3 Mile Island nuclear plant, and we've actually placed those towers at the location of the real cooling towers, and we've just dropped in a few, just for atmospheric effect, the clouds and the rain. Etc. The camera, by the way, is an icon that you can place anywhere on the scene that allows students to click on, and their camera will actually just move to that spot automatically. Okay, my alarm tell me that my time is up. I've got 2 more slides. This is the Elk River chemical spill. If you remember, a year ago, there was a spill, and there was a company called Freedom Industries. I think that's a very ironically named company. Freedom Industries, with those containers, they were leaking chemicals into the river, and then you had a water distribution centers somewhere down the river that was actually pumping the water to around 300,000 people in the neighboring counties. So it was a major issue. The next slide shows the Al-Zatari camp, and on the right, I've just dropped in a few tents and a few healthcare stuff and took a picture inside. But you can imagine having scenarios that can be played in those environments, and that would be more interesting because we're actually referring to something that's happening in the real world. This slide shows it's a data visualization example. I just took some data for the top 10 income per capita locations in NYC and showed how it's, we have a RezMela library object that allows us to, place the...
Ramesh,
Yes.
I'm sorry to interrupt, but that's time now, sorry.
Yep.
Thank you, Ramesh, for the terrific presentation. As a reminder to our audience, you can see what's coming up on the conference schedule at conference.opensimulator.org. Following this session at 2:30 p.m, we'll be in search of turnkey education simulation giveaways. We encourage you to visit the OSCC 15 Poster Expo in the OSCC Expo Region 3 to find accompanying info on presentations and explore the hypergrid tour. Resources in OSCC Expo 2 region, along with sponsor crowdfunder booths located throughout all the OSCC Expo regions. Thank you again, Ramesh.
Right, thanks.